Hello everyone, today we're going to be talking about energy. Now, energy refers to the system's ability to do work or to make something happen. I think talking about energy sometimes seems abstract, but think of it as the ability to do something. When you go and push a table, pull a table, walk, eat, all these activities, including breathing, everything requires energy. And there are many different forms of energy. We have kinetic, we have potential, we have elastic, we have mechanical, and we have other forms of energy. But for the MCAT, there's only a few that you need to focus on. Now, the first one we want to consider is kinetic energy. Kinetic energy is the energy of motion. Think cars, think about planes, and the formula is 1 over 2 mv squared. So, kinetic energy is in units of joules, and it's a good idea to think about what units joules are, because unit conversion dimensional analysis helps you a lot on the MCAT. So remember that. So we go to the other side. The other side is 1 over 2 mv squared. Mass is in kilograms. Velocity is squared. So that means that the units are kilograms times meter over second squared, which means that it is equal to kilograms times meter squared over second squared. That's equal to joules or kinetic energy. So just keep that in mind. It helps a lot, and it might help you find out the units for a formula if you forgot it. And something to know again is that this is speed, not velocity, and it is not acceleration either. Potential energy refers to the energy that is related to the object's position. So think about holding a ball and bringing it from the ground and just holding it and you just let it go. That is potential energy. It just falls down. Why does it fall down? Because of exactly gravitational potential energy. And that means that it depends on the object's position with respect to some level. And that would be the concrete, the grass, it depends. Which is a zero potential energy. Like that, it has zero potential energy. There's no more pull bringing it down. And the formula is U equal mgh. M is mass, g is the constant for gravity, which is 9.8 meter second squared. Now, notice that it is second squared, not meter over second. This means that it is not speed. It is acceleration. Keep that in mind. Something, when it's going down, becomes faster and faster, assuming negligible air tension. And so it's mgh, mass times height times g. This is why it is easier for you to levitate or jump in, like on the moon, if you've ever seen those videos. They almost like levitate and they jump higher. That's because the gravity constant in the moon is lower than Earth. So the gravitational pull is less and it's weaker. Another type of potential energy for the MCAT is elastic potential energy. This, of course, is talking about springs. So if you have a spring right here, and then let's say that I end up pulling it. So imagine that here I pull this. This gets you this elevated spring. Imagine that there's something here holding it. So this spring, once you hold it and you're pulling it, you're stretching it, there is a pull to go to its rest position. Like it wants to go back to its rest position. And it's kind of similar to gravitational potential energy. It's trying to reach a zero potential energy position, trying to reach equilibrium. So if a spring is stretched, or if it's compressed, or if it's very, very close together, from its equilibrium length, then it has elastic potential energy and it wants to go back. And the formula for that is U equal 1 over 2 kx squared. K is the spring constant, and this is unique to the specific spring that you have. And oftentimes the MCAT is going to give you that number, so you don't have to calculate anything. X squared is the magnitude of the displacement from equilibrium. And this is, for example, like if this was moved like 2 meters, it would be 2 over squared for x squared. Total mechanical energy is the sum of the object's potential and kinetic energies. So anytime you have an object, let's say that you hold just think of a cannon. Imagine a cannon that's not going vertically, or it's not going exactly horizontal. It's somewhere in between. It's a 45-degree angle. When it has kinetic energy, which pushes it to a specific direction, and gravitational potential energy pulling it downward to Earth. So that means that it has mechanical energy, and that's the sum of both the potential and kinetic energy. And the unit for that is E. So E is equal to U, which is potential energy, plus K, the kinetic energy. Now, when talking about energy, there comes this important thing that needs to be clarified, which are called conservative forces and non-conservative forces. What do I mean by that? When you have conservative forces, they are path independent. It does not matter how you do it. They're always going to take the same amount of energy. And a great example is gravitational versus electrostatic force. So think about, let's say, and you can also think about displacement and distance. It's going to help you think about it, okay? So let's say that you have a ball, okay? And you want to go from A to B. So you can go straight, or you can go this zigzag road that ends up reaching the same point. Say they end up reaching the same point. When you have conservative forces, these two things take up the same amount of energy. So E1, let's say for this path, and then E2, it would be E1 is equal to E2. Now, electrostatic forces are conservative most of the time, but they could also make it non-conservative. So it depends how the MCAT phrases it, and if it tells you or if it doesn't. But oftentimes, when you see it, unless they tell you, assume that they mean conservative forces. Now, when the work done by conservative forces is zero, or when there are no non-conservative forces acting on the system, the total mechanical energy of a system remains constant. This makes sense. Let's say that you have a cannon, okay? The cannon ends up pushing an object. It's pushing an object. So the path, it's gonna go up, 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 up like that, and it's gonna fall here. This is where the ball is gonna go down to. And imagine that let's say that it goes around here, and like that. And this is the earth, like this is ground level. So all the potential energy and all the kinetic energy, when potential energy gets converted to kinetic energy, and if you try to add them up, or if you try to subtract the energy from potential and kinetic from the final position to the initial position, they both have the same amount. Now, in real life, this does not happen. When you shoot a ball from a cannon, it lands, it does not move. It just stops completely. This is because we have non-conservative forces in reality, and these are also path dependent, which is a difference, because conservative forces are path independent. And the larger the path distance, the more energy is gone. So think about this example that we've had here. When you go from position point A to point B, if you had conservative forces, then E1 is equal to E2. But in reality, E1 is not equal to E2 because we have non-conservative forces. For example, friction. When you're moving a ball this way, that way, it's going down, it's moving a larger distance than E1. This is going to take more energy. This is going to end up slowing the ball more and more and more. So it ends up being lost from the system. A reminder though, not from the universe. It often ends up getting changed to heat energy, and it dissipates this heat energy. So I'm talking about the system, and that's important because sometimes because there's a difference between the system and there's a difference between the universe. The universe includes everything we can think about. Imagine stars, imagine everything in the galaxy, the Milky Ways, everything in existence. The system, though, is something that we define. It could just be this cannon that we have. It could just be a ball that you're holding and it ends up falling down. You decide what the system is, and the system is different from the universe. The two formulas that you should think about is delta E is equal to delta U plus delta K, and those are going to be equal to 0. And non-conservative forces, delta E is equal to delta U plus delta K, and this is not equal to 0. Because remember, some is being lost, which means that the final energy is different from the initial energy. Like there is a difference between them. And what that means is that since they're both, when they only have conservative forces, you can end up finding out what the kinetic energy is and what the potential energy is, because you can just get them to one side. Say this is negative delta U, this is equal to delta K, and then you can end up solving for mass. You can solve for height, velocity. So it depends on the constants that they give you and the information that you have. This is a brief overview of energy. If you have any questions, please leave a comment and I'll try to get back to you as soon as possible.